These are the pieces already cooked, aluminum for the pump. So this is the bottom part, and this aligns with this center piece. And then this is the upper part, and it goes like this. And this call for these gears, and these are 90 each. They go here. But before that, we had to modify our brushless motor to change this size of the shaft. We had to put it here on the back, since this motor is going to be attached to this piece by screws. So the way that we do that conversion is taking this little piece that lock this axis here, this axis with this C lock, and then there is a screw here, a screwdriver, and then we separate both pieces here. And now we have to push this rod a little further down. The way of pushing this rod down is evenly with the press. So I'm going to make a hole here, and then with the help of the press I'm going to push it down. There is a brush washer here inside, so you have to verify. If there is no there, you have to be here on the top. But we had to assemble this one back. Put it together. Okay. I had separated the axle from the body of the motor, the magnets, and you see that it has a groove here, and it has this one where the C lock was present. So since this one has to go here inside, and it has to have, here will be an O-ring. This screw that is here, it cannot interfere with that O-ring, so it has to be in the part of the motor here. I had to make another groove here for tightening this screw when I put it back. And I had to connect this gear here. I'm sanding a little this axle, so it will be easy to assemble here when I put it back. Following with the assembly, I took this little piece of raw. This is like 3.175 millimeters raw, and this is a Dremel tool that I have a little wear here. So I took this little piece out of there with the same Dremel, and this is the piece that goes here on this gear, so the gear can spin freely. And then we can continue with the assembly. This part here is the other gear that is with the shaft of the motor. And this part goes here. And then the little gear with the little rod is going there. With the screw that the motor brings, we can attach now to the base of the pump. This gasket or O-ring, we have to put it on the motor shaft. And then using some hydraulic oil, we have to lubricate this part here. And we proceed with the assembly. These are the hose features, and they are M5, and they had to be screwed these holes. One is for the intake, that is this bigger one, and this is for the output. Next step is installing this O-ring. This is a 23mm O-ring, and it's going to go on in this parameter here around this piece. And I'm going to use some oil also. The remaining piece is adding this O-ring here, O-ring, not this washer. And then the magnets of the motor. After finishing my first version, I realized that I have some issues, and I'm using this tray because this is full of oil. First, I was having only 4 screws here, and this was pressing all these pieces with the same force. So here at the end, I was having this O-ring, and it was pressing it so tight that the engine shaft was having difficulties to rotate. So for that reason, I did the other design. I'm going to show you now. So this is the new design. Starting from the top, here we see the previous one. It was having these big holes here, and it was not sealing this part here on the top. So if you put it like this, yes, it was having this opening here, at least on the touching here. So I was thinking that was causing a low pressure performance. So what I did, it was closing these ones here with no machining the whole thing to the end, leaving a little bit there. So I have those two. And then I also have these screws here, 4 screws, to control how much pressure I can apply to this part here on the front. And then with the other 4 screws, I can control how much pressure the O-ring that is going to go against the motor. So that works to control that part, but I don't know what is failing. Let me see if I can focus here. But it's only giving me like 25 psi when it should be 300 psi, or that's equivalent to 300 psi is around 2 MP. I think it's megapascal. So I don't know what is the issue here with this part. They are flush here, and I see that there is a little bit of wiggle room here, but it's not that much. And then if the tolerances are more tight, then the motor have difficulties to rotate these gears. So the theory is that the oil enters, for example, here, and then this gear goes like this, and the oil goes around the gear, and then exits to this one at high pressure. But then this part is not leaking here. But then the motor part having an O-ring here, and this O-ring is leaking sometimes. And then because the motor is spinning, it's spraying all the oil around, and it's a big mess. So that's the part of this thing that I don't like. So I will assemble it, and so you guys can see what I'm talking about, and I will show you how I'm measuring the performance of this pump. I open 2 ideas. I really want this little project to work. If you have some experience with these guys, you can leave me a comment down, and I will read it and try to improve. Other thing is maybe that this pump is not aligning correctly with this top part and causing some issues. So I don't know if this little bit of movement that this gear has, maybe the tolerances here are not tight enough to create a seal on the oil. By the way, the oil that I'm using, I'm going to show you. So this is the oil that I'm using. It says Jack oil, and it doesn't say what is the ISO of this one. It says SUS S145, but I don't know. This I guess should be 32. I'm going to research on that also. So yes, I did the research and it says that it's ISO 32 hydraulic jack oil. I'm going to assemble now the pump and to be able to show you guys what is the issue that I experienced. So here is already tied, this part. What I'm going to do is, since I'm seeing this assembly, I'm seeing that here there is a mark of friction. So I guess that this gear is more tall than the other one. And that was another modification that I had to do. Like the original gears, they have a little chamfer here. So I have to go with the Dremel and then put it, and then with a little sandpaper, put it to the end that both has the same height. So right now I'm going to do that, and then I'm going to come back and assemble it again. What I have done here to try to repair this is measuring the height of these ones. So it's 6.4 millimeters, 6.04 and 6.04, 6.04. And then in this one, I think somehow big difference, and this one can be also the issue, the thing that is causing the issue, no? Because this is 587, 594, 601, 605, 01, and then 590 is like I have a big dip here of seeing a difference of 0.15 millimeters. So I'm going to try to repair that and see if it somehow works. Okay, it's still rotating, and it's not difficult. You can tighten it more. Okay. Still rotate. Okay, we can proceed now to install the motor. Okay, this thing got really tight now here. Okay, it moves more freely, but then that O-ring that is really important there to avoid that the oil is escaping through the bag is not being pressurized. Okay, rotates tight, but at least it's rotating. Hope that it's going to start working. Let's see. Okay, this is my setup. I have this painting tray to collect all the excess oil that leak. And here I have my oil. And then here I have this T that split the pressure line from the pump to this instrument that measures the pressure. And I have these drains to put some oil and put it into the line so the pump will not run dry. Let's go and test this modification. Okay, here we have some leaks already. So I have to start tightening those screws. So we have some pressure going here. Okay, that is like 30. PSI. Here, this is the test. We have some flow going here. And then a low resolution, like close this one. Yes, like barely going up. Okay, here's the RPM. We have more flow. What barely is you get 10 or 20 PSI. Okay, the maximum pressure that I'm getting here is 20, I think maximum 30 I have reached. And this is getting really hot. Okay, we have some oil that is spraying again. Yeah. So this is a mess. So yeah, guys, I am officially giving up on this project. I don't know what else to do. I know that I have some tolerances that I'm not meeting for the gears on the upper part. Maybe something, but I will need some precision tools like a lathe or something like that to face that gear, and that is evenly in all the circumference. So thinking about that, or putting some tools to rotate it and put a sandpaper or something. But that is something that I think is contributing to the low pressure. Any suggestions? Guys, you let me the comments down, and maybe I can try it. I have seen on AliExpress there is a pump that I put it on the screen right now. This pump is for a car, so they sell like the module, like aluminum block or steel block with the motor attachment, and if the pump is only like I think 16 or 17 bucks, and if the pump goes back, you only buy a new one, and that's it. The only thing that I don't like about that is that it's big. So this is 30 by 30 millimeters, and that one is like 46 by 46, and I think it's even deeper than this one. So I think I'm going to try to get that one and see how it goes, and maybe I can then focus on doing the valves or doing the next project. I will see. I want to do an excavator, so I had to check which one, what size, and which one to start designing. So thank you very much, guys, for all you reached to this part of the video, and hope that you like it, and subscribe if not subscribe right now, and thank you very much for watching and stopping over. Bye.